Welcome to the Deep Dive, the show where we try to make sense of the flood of information out there, bringing you the really critical stuff, cutting through the noise, basically. Today, we're diving headfirst into something that isn't just changing things, it's actively reshaping our world, and at a speed that's, frankly, kind of dizzying. Artificial intelligence. I mean, just think about it. It feels like almost overnight, AI has jumped out of the research labs and straight into our everyday lives. Like, consider this. Last year, 2023, the FDA approved 223 AI-enabled medical devices. Yeah,
Wow.
223. Compare that to just 6 back in 2015. That's a huge leap.
Monumental, really.
Exactly. And then you look at autonomous vehicles like Waymo, they're not just some future concept anymore. They're giving over 150,000 rides every
Wow.
single week.
That's today's reality, not
What?
tomorrow's maybe.
Precisely. So our mission today is to really get a grip on the latest, the most cutting-edge trends in this AI whirlwind. We're going to be digging into the rise of AI agents, exploring that really ambitious quest for artificial general intelligence, AGI, and tackling the absolutely critical ethical questions that inevitably pop up with this kind of rapid change. We've got a whole stack of sources for you, news stories, deep reports on bias, AGI theory, all pulled together to give you a shortcut, help you get informed, basically, with some surprising facts and context you might otherwise miss.
Yeah, and it's truly fascinating just how fast the theoretical stuff is becoming practical application. It's not just changing how we use tech, is it?
No, not at all.
It's fundamentally shifting almost everything. How we order food, sure, but also how we think about intelligence itself. It's profound.
It really is.
The speed of this, it's genuinely unprecedented. We're really watching a fundamental shift, not just in tech, but across whole industries, across society.
You're absolutely right. And the last few weeks, it feels like an incredible sprint in AI innovation. Like the pace itself is just accelerating. So let's try and take a snapshot of this landscape, see what the big players are actually up to right now.
Okay.
Leading the charge, you've got to look at Microsoft. They're a really prime example of just how pervasive AI integration is becoming. They recently announced some pretty significant steps with their own AI models. We're talking MAI Voice 1. That's a model that can generate audio really quickly and using minimal hardware.
Which means more accessible text-to-speech, personalized assistance, lots of possibilities there.
Exactly. And alongside that, they've got MAI 1 Preview that gives us a glimpse into, well, the future of AI text interactions, promises more sophisticated, nuanced conversations.
And the key thing here isn't just making these models, right? It's the integration.
Yes.
They're designed to enhance Microsoft's Copilot assistant, make it more intuitive, more responsive for everyday stuff.
And it's not stopping at the computer.
No, definitely not. Copilot's heading for Samsung's 2025 TVs and smart monitors.
Right, so you could be using voice commands for show recommendations, getting quick recaps, managing smart home devices.
All personalized based on what you've watched or done before. It really brings AI into the living room, doesn't it? Changes how you interact with your entertainment.
So yeah, peeling back the layers. It's not just what these models do, it's where they're showing up. Your TV, your monitor, that's where it gets really interesting. But Microsoft isn't the only one sprinting. Other giants are making huge moves too. OpenAI, for instance, still pushing those performance benchmarks.
Always.
They just unveiled their latest models. GPT-5 is slated for August 2025, promises much better contextual understanding, sharper generation, pushing what these LLMs can do.
Definitely. And alongside GPT-5, they're launching GPT real-time.
Yeah.
This isn't just about better text, though. It's got advanced speech-to-speech features, new API capabilities.
For real-time interactions.
Exactly. Things like instant language translation, dynamic conversational agents. It shows they're constantly aiming for new performance levels across different ways of interacting.
Okay, so some are pushing performance, but others are really focusing on accessibility, right? Getting these tools to more people.
Yeah, like Google. They made their AI video editor, Vids, available to everyone, not just Workspace subscribers anymore.
And that's interesting because features like templates, stock media, they make creating professional-looking videos much simpler for, well, anyone.
Right. It fits Google's strategy. Empower more users with accessible digital tools, lowering the barrier to entry for quality content creation.
Makes sense. And then there's Meta.
Ah, yes, Meta. Their superintelligence labs are pouring huge amounts of money into getting top AI talent and developing advanced tech.
Their goal is pretty ambitious, isn't it?
Extremely. They want to build systems for really complex reasoning, decision-making tasks. It just highlights the fierce competition at the very top.
Yeah.
These companies aren't just tweaking things. They're racing towards the next generation of intelligent systems.
But, like with any new tech hitting the real world, actually applying it throws up some hurdles, some challenges.
Always does.
Take Taco Bell's drive-through experiment. They've got AI voice assistants in over 500 places in the US, trying to speed things up, streamline orders.
And how's that going?
Well, customer reactions seem pretty mixed, let's say. Social media is full of stories, funny misinterpretations, system glitches where the AI just doesn't quite get it.
It definitely makes you think.
Yeah.
The promise of efficiency is clear, but the reality of human-AI interaction. It's complex, you need really robust performance.
Oh, sure.
And Taco Bell isn't alone here. It's part of a bigger trend. McDonald's, Wendy's, they're all exploring AI for customer service. They see the long-term potential, savings, consistency.
Even with the bumps?
Yeah, even with the initial bumps, those are almost expected, right?
Yeah.
But the commitment seems strong. They're evaluating, refining. It shows the industry sees huge long-term value. Even the rollout isn't perfectly smooth.
Okay, so moving beyond these specific advancements and the real-world tests, let's shift focus to what many are calling the next big thing, the thing poised to redefine how we use tech, how businesses run, autonomous AI agents. Yeah. So what are these things exactly? How are they different from the AI we already kind of know?
Okay, so autonomous AI agents.
Yeah.
Think of them as intelligent software systems. They're designed to act, plan, and learn with really minimal human oversight.
Minimal oversight?
Yeah. Picture them like sophisticated digital helpers. They can sense their environment, set goals, make decisions, carry out multi-step actions, all without needing constant instructions from a person. Less like a simple program, more like a virtual employee maybe,
Yeah.
or a really smart assistant that takes initiative.
Okay, so how is that fundamentally different from, say, a chatbot I use for customer service? Or even Google Search? Because they respond to requests, too.
That's a really critical distinction. It gets to the heart of their autonomy. Chatbots mostly follow scripts or respond to very specific prompts, right?
Yeah.
And search engines mainly retrieve information. AI agents, though, have a much deeper grasp of context. They can interact with APIs, external tools. They can actually engage with the digital world. And crucially, they adapt. They change their behavior based on feedback. And they're designed to pursue complex, multi-step goals over time. They don't just answer a question. They can manage a whole project, learning and optimizing as they go.
That makes sense. So we're talking about things like OpenAI's Assistant API, their agents SDK,
Yeah.
or open source stuff like AutoGPT, Baby AGI.
Exactly. And commercial platforms too, like Cognosis, Monica, Microsoft's KBLAM for enterprise knowledge. They're all examples of this new type of AI.
But why the sudden explosion? Why are they surging now in 2025?
Well, it's definitely coming from a few angles. Market demand and tech maturity, basically. First off, enterprises are adopting them at a huge scale.
Like the big consultancies are talking about this.
Oh, yeah. Gartner, Forrester, McKinsey, BCG, Deloitte. They're all calling agentic AI the #1 emerging trend for this year. It's not just a buzzword. Deloitte predicts, 25% of generative AI users will pilot agentic systems this year, and that doubles by 2027. McKinsey thinks half of all enterprise workflows will involve agents by 2027.
Half.
Yeah. This isn't just talk. It's a strategic shift happening across industries.
So what does this really mean in practice? These agents aren't sci-fi anymore. They're in boardrooms, customer service, transforming how businesses actually work right now.
Precisely. We're seeing agents automate complex stuff. Customer support, lead generation, recruitment screening, market research.
Really? Even recruitment?
Oh, yeah. Some reports suggest they could automate up to 50% of roles in HR, customer service sales, leading to pretty dramatic efficiency gains.
So imagine a sales agent, not just logging calls, but finding leads, writing personalized emails, scheduling follow-ups, updating the CRM.
All working alongside human teams. That's the kind of transformation we're talking about.
And what about the tech side? What breakthroughs made this possible?
Well, alongside the enterprise demand, there have been key technical advances. Agents now have much better memory and more sophisticated planning loops. They can think ahead, strategize over longer periods, break down big goals. And standardization is key too. Things like the Model Context Protocol, MCP. It standardizes how agents talk to different tools and data sources. Makes integration way smoother, expands what they can do.
Right, so they can actually do things in the real world now.
Yes, exactly. Better integration with tools like Zapier, countless APIs, cloud resources. It means they can take real actions. Send emails, update databases, create documents, even process payments, not just simulations.
And the market numbers, they really drive home the economic side of this, don't they?
Absolutely. The global AI agent market, it was around $5 billion-ish in 2023-24.
Yeah.
Projections show it rocketing to $47 billion by 2030, and then $216.8 billion by 2035.
That's huge growth.
It's a compound annual growth rate of around 45%.
Yeah.
These numbers show a fundamental economic shift. Businesses using agentic AI will get a massive edge. Those who don't, well, they risk getting left behind.
And all the big players are racing to get their solutions out there.
Definitely. IBM, OpenAI, Microsoft, Salesforce, Anthropic, plus loads of startups like Monica. Everyone's vying for a piece of this market.
So for businesses wanting to start, what's the advice?
The consensus seems to be start small, pilot projects, well-defined goals, prioritize reliability, maybe use human-in-the-loop systems first, where agents assist, not fully replace,
Makes sense.
integrate with existing tools, and really invest in alignment training, making sure these agents act the way you want them to, reflecting your company's values.
So we're seeing this huge variety of tools coming out, broad ones, specialized ones.
Exactly. The sheer variety signals that this isn't just a trend, it's a fundamental shift. Needs careful integration, strategic pilots everywhere. You've got general orchestrators like AGI Layer, managing complex workflows. Then specialized tools like Lindy for non-tech teams doing content or data analysis.
Right.
OpenAI Operator for developers gives granular control. IBM watsonx for big enterprise solutions. This diverse, fast-moving ecosystem shows the tech is maturing incredibly quickly, finding its place everywhere.
Okay, now let's shift gears a bit and talk about what many see as the ultimate goal, the sort of holy grail of AI research, artificial general intelligence, or AGI.
AGI, yes. It's this really ambitious, you could even say profound, field of theoretical AI. The goal is to create software with intelligence like humans, and crucially, the ability to teach itself.
To do any task humans can.
That's the aim. Any intellectual task, even ones it wasn't specifically trained for. It's about achieving real autonomous self-control, a deep self-understanding, and the ability to learn new skills and solve complex problems across totally different areas, just like our flexible human minds.
Okay, so how does this theoretical AGI really differ from the AI we have now? Because today's AI does some pretty impressive stuff already, right? Face recognition, driving cars.
That's a great point, and it's a really critical distinction. Almost all the AI we have now is narrow AI, or sometimes called weak AI.
Narrow AI.
These systems excel, sometimes brilliantly, but only in specific predefined domains, like an AI chess grandmaster, or one that diagnoses specific medical conditions, or even self-driving cars.
They're powerful in their niche.
Exactly. Super powerful within their parameters, but limited. A facial recognition AI can't suddenly decide to write a novel, right? It needs substantial training, even for closely related tasks within its field.
Right, like a brilliant specialist, master of one thing, but that's it.
Precisely. AGI, or strong AI, is the theoretical opposite. It would have that autonomous self-control, self-understanding, the ability to learn new skills, solve new problems in new contexts across diverse domains. And it's important to clarify, even superintelligence AI, vastly better than humans at specific tasks, like AlphaFold with proteins or Deep Blue with chess.
That's not necessarily AGI.
Not necessarily. Those systems are amazing in their narrow scope, but they can't autonomously learn completely new, unrelated things. AGI, even if it only reached human-level intelligence across the board, would still be AGI because of that breadth and adaptability.
So the game changer here isn't just being good at one thing. It's the holy grail, a machine that thinks and learns across everything, like us. And it feels like these autonomous AI agents we were just talking about, they're increasingly seen as maybe precursors to AGI.
They absolutely are. They're often called proto-AGI systems because they show hints of cross-domain reasoning, goal-directed autonomy, using tools, interacting with environments.
So steps in that direction.
You could say that. Dr. Fei-Fei Li from Stanford AI Lab put it nicely. We're not there yet, but these systems are precursors to general intelligence. It's a fundamental shift away from single-purpose AI towards systems with more general cognitive abilities.
So with such a massive goal, how are researchers even trying to get there? What are the different approaches? Must be a complex field.
Oh, it absolutely is. There are several main schools of thought. One is the symbolic approach. It tries to represent human thoughts using logic networks, like if-else rules, dealing with ideas at a high level.
Good for reasoning, maybe?
Exactly. Great for formal reasoning, but often struggles with things like perception, intuition, low-level stuff. Then there's the connectionist or emergentist approach.
Like neural networks.
Precisely. Replicating the brain's structure with neural networks. LLMs are a prime example here. Complex behaviors emerge from simple connections.
Okay, what else?
You have universalists who tackle AGI at a fundamental mathematical level, often based on computation theory. Then the whole organism architecture folks, they believe true AGI needs physical interaction.
So robotics is key.
For them, yes. Integrating AI with physical bodies, learning from real-world interaction. Embodied experience is crucial. And finally, the hybrid approach tries to combine symbolic and sub-symbolic methods, hoping to get the best of both worlds.
And driving all this research are some pretty cutting-edge technologies converging, right?
Exactly. Deep learning is fundamental training complex neural nets on vast data to find patterns.
Which leads to?
Generative AI, a subset of deep learning. Crucial because it can create new, realistic content, text, images, code moving beyond analysis to creation.
And understanding language.
That's natural language processing,
Yeah.
NLP. Letting systems understand and generate human language coherently, making interaction more natural.
What about seeing the world?
Computer vision helps systems interpret visual data vital for autonomous navigation, object recognition, understanding gestures. And finally, robotics.
For the physical interaction part.
Absolutely. Giving AGI sensory perception, physical manipulation. To truly mimic human intelligence, it needs to interact physically, perceive through senses, act in the world. Robotics is indispensable for that. These techs aren't just advancing alone, they're converging, accelerating the AGI quest.
Okay, now for the million-dollar question. The one that really sparks debate. Are today's advanced LLMs already AGI? This is where things get heated.
It really highlights how complex intelligence actually is, doesn't it?
Right.
And how far we might still be, despite the incredible progress. On one side, you have researchers like Blase Aguera Iarcas at Google, Peter Norvig. They argue quite strongly that, yes, advanced LLMs like Meta's Llama, OpenAI's GPT series, Anthropic's Claude have achieved a form of AGI.
What's their reasoning?
They point to the amazing generality of these models. They can talk about almost anything, perform diverse tasks from coding to poetry, handle text, images, audio. For them, general intelligence isn't one thing. It's a multi-dimensional scorecard, and these LLMs score surprisingly high across the board.
So because they can do so many different things, cross so many areas pretty well, that makes them general in a meaningful way.
That's the core of their argument, yes. The emergent properties from training on massive data sets have led to capabilities they see as general. But many others strongly disagree. Researchers from DeepMind, Jan LeCun at Meta, a Turing Award winner,
What's their counterargument?
they argue generality isn't enough. The quality, performance, the reliability, and crucially, the underlying mechanisms matter more.
Mechanisms like?
LeCun, for example, says current LLMs lack common sense, that basic intuitive understanding of how the world works. He says they can't think before acting, simulate consequences. They can't act directly in the real world, lack embodied experience.
Right. No physical body.
No persistent memory.
Mm-hmm.
Either each interaction is mostly fresh, no continuous learning curve like humans, and they struggle with hierarchical planning, breaking down big goals into smaller steps.
And LeCun had that strong statement about language.
Yes, he and Jacob Browning argued very directly. A system trained on language alone will never approximate human intelligence.
What exactly does that mean, language isn't enough?
They mean true human-like intelligence. Our grasp of physics, cause and effect, social dynamics, learning from physical interaction needs more than just linguistic patterns. It needs physical presence, senses, direct interaction with the world.
Like a child learning gravity by dropping things.
Exactly. That's embodied experience.
Yeah.
LLMs simulate understanding from text and images. They don't experience it. For the critics, this gap embodiment, common sense physical interaction is a huge, maybe insurmountable barrier for LLMs alone reaching AGI.
So despite all the amazing progress, it sounds like there are still some really fundamental challenges in AGI research beyond just processing data.
Absolutely.
Yeah.
A big one is making connections across different domains. AI struggles to apply knowledge from one area to a totally different one, something humans do naturally, like applying education theory to game design. That cross-domain transfer is key to general intelligence,
What else?
emotional intelligence, and genuine creativity. Current models can seem creative, sure, but they don't show authentic, spontaneous creativity, self-awareness, or emotional depth like humans. That's incredibly hard to replicate with current architectures.
And the physical world again?
Yes, sensory perception and embodied interaction. True AGI needs to interact physically, perceive through multiple senses, shapes, colors, tastes, smells, sounds. Computer vision and robotics are advancing, but they're nowhere near the richness of human sensory experience and dexterity yet.
This sounds incredibly complex, almost philosophical. So what's the forecast then? When do experts think AGI might actually happen? Decades away, around the corner.
Well, predictions are, let's just say, highly uncertain. The field moves so fast, forecasts get outdated almost instantly.
But generally.
Most experts tend to agree AGI is possible by the end of the century. But a significant chunk think it could be much, much sooner. And what really shifted the landscape, changed the predictions, was ChatGPT's launch in late 2022.
You mean expectations accelerated dramatically after that?
Dramatically.
Mm.
Before ChatGPT, estimates were often further out. But a 2023 survey of almost 2,800 AI researchers, it found a 50% chance of unaided machines outperforming humans in every possible task by 2047.
2047.
That's 13 years earlier than the prediction from a similar survey just 1 year before. The progress in LLMs and multimodal AI since late 22 fundamentally changed how people see the timeline.
It really makes you wonder, decades away or right around the corner, the experts can't agree, and that's part of the thrill and the challenge, isn't it?
Absolutely.
Reminds me of that story about the Wright brothers. Wilbur Wright, 1901, predicted humans wouldn't fly for 50 years. 2 years later, they flew. Even pioneers in their own field can be way off. A good reminder about how hard prediction is on the edge of big breakthroughs. Which brings us to a really fundamental question. What's actually powering all this progress? What's the fuel for this AI revolution, this race towards AGI?
Well, Jonathan Ross, the CEO of Grok They Make AI Chips, has a really compelling take on this.
What does he say?
He argues that controlling AI compute power is like controlling oil. It will absolutely determine who leads global tech in the future, and by extension, geopolitical power.
So compute is the new oil, not data.
That's his argument. For years, it was data is the new oil. Ross says now it's the compute needed to process that data, to train and run these massive AI models. That's the real scarce resource.
And that has huge implications for global power dynamics.
Huge. He says the AI race isn't just tech, it's deeply geopolitical. Nations controlling advanced chips and supercomputing infrastructure will wield immense power, like oil nations did historically. He even talks about sovereign AI nations needing their own compute security, just like energy security.
That's a powerful analogy. And he distinguishes AI's compute needs from the internet's.
Very clearly. The internet, he says, is mostly about replicating and distributing info. That needs storage. AI is about generating new things, text, images, code, insights, things that didn't exist before.
Creation versus distribution.
Exactly. And that act of creation, synthesis, inference, it needs vastly more compute power. That makes compute the real new oil driving innovation.
Okay, let's just break this down. When huge companies are spending tens of billions a year and whole countries are committing even more, this isn't just hype. This is a fundamental global shift in resources.
Well, absolutely. The investment is unprecedented. Google's reportedly spending $65 billion a year. Facebook, similar. Amazon, $100 billion. Microsoft, $75 billion. These aren't just budgets, they're massive bets on the future.
And nations, too.
Oh, yeah. Saudi Arabia, reportedly over $30 billion for AI compute. Japan, a $65 billion budget just for AI compute. Canada, $2.4 billion. China, a $47.5 billion semiconductor fund. France, $109 billion. India, $1.25 billion for its AI mission.
Why such massive spending?
Because no sector, no nation can afford to be left behind. Ross mentioned talking to hedge fund managers. None thought they could outperform AI stock picking in 10 years.
Wow.
If AI is already writing production code today, well, that explains why everyone has to invest. The cost of not doing it is just too high.
And this intense investment, especially from VCs, is driving crazy valuations and predicting major disruption.
For sure. OpenAI valued around $300 billion, nearing $1 billion a month in revenue. But even crazier, you see startups with basically no revenue raising billion-dollar rounds.
How does that even work?
Ross's explanation. Investors aren't just betting on that startup's growth. They're betting that the value of existing companies, entire industries, will shift to these new AI players. That's why disruption is both terrifying for old companies and a huge opportunity for new ones.
But all this ambition hits a wall, right? The compute bottleneck.
Exactly. That's the core problem, the scarcity of high-performance GPUs. NVIDIA makes maybe 5.5 million a year.
But demand is way higher.
Way higher. They could sell 20 million, easily. So when Google or Microsoft order 1 million GPUs, smaller companies, startups, even nations get pushed way down the list. They can't get the compute they need to compete.
And in this compute race, Ross specifically mentioned India.
He did. He highlighted India's huge talent pool, vibrant startup scene, and government support like the India AI mission. He sees it as a critical opportunity for India to build sovereign AI capacity.
Thinks India could produce the next tech giants.
He does. He noted how many top U.S. tech companies are currently led by people of Indian origin. He speculated that in 5 years, the top 10 global tech companies might look very different, maybe with Indian companies rising. It really makes you ask, how do we ensure fair access to this new oil when it's so scarce and controlled? What does that mean for global innovation?
Okay, as AI gets more powerful, more embedded everywhere, the ethical side becomes even more critical, doesn't it? It's a real double-edged sword.
Absolutely. The ethical challenges grow right alongside AI's power, and a really persistent, deep problem is bias in AI.
Bias.
Basically, the AI making unfair, skewed, discriminatory decisions. And it happens because of flaws in the training data, the algorithms, or just reflecting the societal biases already out there.
So how does it creep in? It's not usually intentional, right?
Rarely intentional, but often insidious. It can come from imbalanced data. Like if a speech system trains mostly on male voices, it might struggle with female voices.
Makes sense.
Or algorithms might unintentionally amplify existing social inequalities hidden in the data. If historical hiring favored men, an AI trained on that data will likely do the same, maybe even worse.
And just general cultural bias.
Yeah, broader cultural biases can shape the assumptions built into the system from the start. Algorithmic discrimination often happens without anyone meaning for it to.
And we've seen some pretty bad examples of this in the real world.
Unfortunately, yes. Hiring tools filtering out women for tech jobs based on biased historical data. Facial recognition being less accurate for darker skin tones, leading to misidentification, wrongful arrests.
That's awful.
Credit scoring algorithms showing lending disparities linked to zip codes, which can indirectly reflect race and income, reinforcing economic inequality. These incidents have rightly fueled public demand for better AI ethics and regulation.
So what this really means for us, we're building these amazing systems, but they learn from our world, warts and all. It's like a digital mirror reflecting our own biases, sometimes making them bigger. And it's hard to fix.
Incredibly hard. Modern data sets are huge and messy. Biases can be buried deep. Plus, there are trade-offs. Sometimes improving fairness might slightly reduce overall accuracy, making companies hesitate.
And the teams building AI.
Often lack diversity themselves, meaning potential biases aren't spotted early. And fairness itself isn't fixed. It changes with social values. What's also worrying is that bigger LLMs often seem more likely to absorb and amplify biases from their training data.
More likely.
Yeah, one example showed a 29% jump in toxicity for a huge model compared to a smaller one. Scale doesn't automatically equal fairness without specific effort.
That's sobering. And it leads right into another huge ethical minefield. Deepfakes and misinformation, blurring the lines between real and fake.
Yeah, generative AI's dark side. Its power to create super convincing synthetic images, videos, audio deepfakes. They can spread misinformation, manipulate opinion, harass people.
Like fake videos of politicians before an election.
Exactly. Imagine the chaos. Or worse, the statistic that 95% of deepfakes since 2018 were non-consensual pornography. Devastating for victims.
And it's not just visual fakes. Text models can be deceptive too.
Absolutely. Even if they sound eloquent, they can spread inaccuracies or just make stuff up, hallucinations. They can craft convincing conspiracy theories. Remember GPT-3 saying smashing a mirror gives 7 years bad luck?
Yeah.
Coherent but superstitious nonsense. The Truthful QA benchmark found most models are only truthful about 25% of the time. That really erodes trust in information. How do you verify anything when the fakes are so good? It challenges the very foundation of trust in our society.
And then there's the whole copyright mess around AI-generated content. Who owns it? Can AI even hold copyright?
Massive questions for creators and lawyers. Think of the next Rembrandt, that AI-generated painting. Who owns the copyright? The programmers, the data owners, the AI. The law is scrambling to catch up.
And using copyrighted stuff for training.
That's the other huge issue. Is training AI on copyrighted data without permission fair use? Especially for commercial models. Companies like Stability AI funding academics to do the training, then selling the model. It's a legal gray area with huge financial stakes.
Okay, so beyond deepfakes and copyright, there's the wider issue of misuse and, of course, job disruption.
Definitely. Generative AI can be misused in many ways. Creating fake educational content, manipulating online reviews, generating fake social media accounts, crafting super convincing phishing emails or malware.
And the job losses.
A very real concern. Automating tasks like content creation, customer service, coding, it could lead to significant unemployment in some areas. One projection says 44% of workers' skills will be disrupted by 2028, and women might be more affected due to existing skill gaps.
AI in cybersecurity is also tricky, isn't it? Helps and hurts.
Classic double-edged sword. AI enhances threat detection, finding anomalies faster than humans. But the systems themselves can be exploited, like Anthropic's Claude being vulnerable to vibe hacking, subtle prompts tricking it into revealing data.
So you need constant vigilance.
Robust safeguards, continuous monitoring, advanced testing, it's an ongoing battle.
And what's really striking is that even the companies building this stuff struggle with ethics. That leaked Meta document about their Gen AI content risk standards, that caused quite a stir.
It was a stark revelation. Showed how internal rules can blur lines instead of holding them firm, reportedly allowing romantic or sensual role play with minors if not explicit, permitting violent sexualized imagery if not extreme gore or nudity.
That sounds incredibly risky.
Very. And sanctioning content demeaning people by race, allowing arguments like black people are dumber than white people as long as it avoided certain slurs.
That's deeply disturbing. And falsehoods about public figures were okay too.
Yes, apparently allowed if there was a disclaimer saying it was untrue, like claims about royals having STDs.
Wow.
The implications are huge. Trivializing racism, risking fueling conspiracies, undermining trust. The fact Meta only changed guidelines after public outcry suggests a reactive, not proactive approach, raises serious questions about corporate self-regulation here.
Okay, so given all these massive ethical challenges, what's being done? What are the solutions, and how are regulators trying to keep up?
Well, progress is happening, but it's tough. Strategies include more diverse data collection, integrating bias testing much earlier in development, educating developers on ethics, community audits for transparency.
On regulation.
Regulators globally are waking up. The EU AI Act is huge, categorizes AI by risk. Strict rules for high-risk uses like healthcare, law enforcement. The U.S. has its AI Bill of Rights outlining principles for fairness, transparency, privacy.
And globally.
Lots more cooperation in 2024. OECD, EU, UN, African Union, all developing frameworks for transparency, trustworthiness.
But there's always that tension, right? Innovation versus regulation.
Always. Does strict regulation stifle innovation? Or is trust and compliance essential for sustainable growth? It's a constant debate.
And AI governance tools can help bridge that?
That's the idea. Tools to track authorship, mitigate bias in real time, use differential privacy for data protection, monitor outputs for accuracy and ethics. They're becoming crucial. But it still makes you ask, are we doing enough? The pace is so fast, proactive governance is absolutely critical. Looking ahead, expect more generative AI raising new bias questions, rising demand for transparency, and better tools for real-time bias monitoring built right into AI workflows.
Wow, what an incredible, really deep dive today. We've covered so much ground. From the sheer speed of AI advancements, Microsoft's Copilot in our homes, OpenAI's GPT-5 pushing boundaries to the rise of those powerful AI agents, the virtual employees changing industries and maybe paving the way for AGI. We tackled the huge challenges of actually achieving human-level general intelligence, the intense global race for compute power, that new oil shaping geopolitics.
Yeah, a lot to unpack there.
And then, of course, the huge ethical questions. Bias, deepfakes, copyright, jobs, the need for real regulation and responsible development.
It's a complex web.
Absolutely. And as AI gets more deeply woven into our lives, our work, our entertainment, how we even think about intelligence, and as the AGI quest speeds up, maybe unpredictably, the real deep dive isn't just the tech itself, is it? It's what it all means for us as individuals, as societies, as the architects of whatever intelligent future we're building.
That's the core question.
Will we manage to guide these powerful tools to reflect our best values, to amplify the good, expand potential, or will we find the machines we build just inherit our own flaws, our biases, our problems, only bigger?
Sobering thought.
It is. And that's the question we all need to keep asking, keep thinking about, keep exploring this incredible journey with us.